Alright, welcome to this next video, which is Introduction to Linear Relations. Now, the learning goal for this one is that you're going to be able to understand linear relations, and you'll be able to, at the end of it, locate x and y intercepts of a linear function, find the linear function for some table of values, and finally to be able to sketch a linear function using a table of values. Alright, having fun with functions. So functions are sort of like a special area of, tool for mathematics, in that I want you to think about it as sort of a mathematical machine. This is our function, okay, and it will, it's some function maybe of x, which means that it takes x values that come into it and then pairs them up with some y values, and spits out the other end an ordered pair. So combine some x and y values together. Okay, and so this function might be 2x plus 3, and so if a 5 comes in, 2 times 5 is 10 plus 3 is 13, and so that pairs up as 5, 13. Okay, so that's what our functions are. We're going to be starting to look at linear functions, but by the end of this unit, we'll probably be looking at some non-linear functions as well. Okay, quickly now, some key ideas. So the Cartesian plane has 2 axes and divides the number plane into 4 quadrants. So let's quickly draw ourselves a Cartesian plane here. So we've got 2 axes. This first one here, I've drawn the y-axis, so I've got negative y down this end and positive y up here, because across horizontally is the x-axis with negative x down this side and x on this side. So this obviously go out to infinity. That's what these little arrows mean. And this point here is our origin. Okay, and that's the point 0, 0. And we've got 4 quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, it's important for you to remember that, because this is quadrant 1, because all of the x values and all the y values are all positive in this quadrant. Okay, so the horizontal x-axis and y-axis intersect at this origin at right angles, obviously. Okay, and that's mostly what you need to know, those basic things there. Now, the position of some point is given by an ordered pair, an x, y, which describes the horizontal and vertical position relative to the origin. So, if we had a axis like this, there's our x, there's our y, some point in here will be described with an x, y value, okay? And that means that it is x distance along here and y distance up here, okay? That's what that means. And this is called an ordered pair because it's a pair of numbers being placed together in order, and the order is important. Okay, so it's always the x value, then the y value. Obviously, if there's more than there, it might be x, y, and z. Okay, so it's very important you remember that order. Alright, a linear relation is a set of ordered pairs which would produce a straight line on a Cartesian plane. So linear relations can be described with a couple of different functions. So we've got y equals mx plus c, and so this might be if you see a function that is y equals, as I sort of talked about before, 2x plus 3. So that's in that one form. You can also have it in this form here, ax plus by plus c equals 0, which they can kind of look like 4x minus 2y plus 5 equals 0, or sometimes this 5 is on the other side, in which case that would be 4x minus 2y equals negative 5. Okay? Now, the x and y intercepts are the points where the function crosses the axis. Okay? So I've got a Cartesian plane here. Now, so these points will be, so here, this is our y-intercept. And this here is our x-intercept. Okay? And what's very important is that you notice this with the y-intercept, we know that that is at x equals 0. Okay? And our x-intercept is always going to be at y equals 0. Okay, see at this point it's in line with the origin, so the y is going to be 0 at that point. So we can easily have a look. Is not only can kind of count it 1, 2. So this y-intercept is going to be at 0, 2, and this one x-intercept is at 4, 0. If you're looking at a table of values like this down here, wherever the x is 0, the corresponding y value, there's our y-intercept, and here is our x-intercept. Okay, so you can either find them graphically by looking at the graph itself and finding where it crosses the axis, or you can have a look down at the table of values and find where the zeros are, and that will help you out. Okay, let's have a look at some worked examples. So we're going to plot the function y equals 2x minus 4. So the first thing is we draw up a table of values like this, and we're going to work out a couple of them. I'll do the first one by hand. So y equals 2x minus 4 is our function. We're going to pop negative 2 in with where the x is. So we've got 2 times negative 2 minus 4. 2 times negative 2 is negative 4 minus another 4 is equal to 8. Negative 8 even. Then for the negative 1, 2 times negative 1 is negative 2, minus 4 is negative 6. 0, 2 times 0 is 0, minus 4 is negative 4. 1 times 2 is 2, take 4 is negative 2. And 2 times negative 2 is 4, take 4 is 0. So there's our ordered pairs there, negative 2, comma negative 8, negative 1, comma negative 6, etc., etc. So we can go about plotting those. I haven't really given myself much of a hand here. Let's pretend that each of these is worth 2. So if I've got x is negative 2, y is negative 8, 2, 4, 6, 8 down here. Our first point is going to be here. Negative 1, comma negative 6. So here's our negative 1, negative 6, so there. 0, comma negative 4, 1, comma negative 2, and 2, comma 0. So as you can see, it's sort of in a line there. Now, it shouldn't be too much of a stretch for you to realize that you only need 2 points to graph a line, okay? But it's a good idea to at least plot 3, because if you plot 2 and you're wrong with one of them, you'll still get a line. But all 3 of them have to be on the line, okay? That's a good idea there. All right, now here's another type of question you're going to run into, which is to describe the axis intercepts of the functions below. So when we've got it graphically, it means we have a look at it here. Okay, so let's pretend we're back to each of these grid spacings being 1. So we count up here, so 1, 2, so that's y is equal to 2. So this point here is going to be your y-intercept is at 0, 2. And this x-intercept, so this is where it crosses the x-axis, at x equals 1 and y equals going to be 0. Okay, so that's the x-intercept at x equals 1, y equals 0. Okay, so that's how you do it graphically. Look at it, see where it crosses, find those values. And if you've got a table of values, remember we're looking for the zeros. Okay, so remember our y-intercept is at x equals 0. Therefore, let's find out x. X is 0 at y equals 4. Therefore, we find it at 0, 4. Our x-intercept is at y equals 0. So we find what that is. It's here. Therefore, it's at negative 2, 0. Okay. So that's that for that video. There's a couple of exercises associated with this one, and some of them might be some new stuff for you. So if there's anything that was confusing or you want a bit more clarification, please don't hesitate to come ask. All right? Thank you very much.